Thank you. So, yeah, as Angel explained, that's the high-level use cases. It's about companies trying to trace their product. So I won't repeat that. Now, there are lots of limitations in the reality how companies work that we had to face as a blockchain project, because most of those companies, they don't know anything about blockchain. They don't know anything about internet sometimes, or computers at large, because a lot of that is still happening on papers and so on. So huge hurdles to integrate with those systems. So how we architected AMB-NET. AMB-NET is not just the blockchain, but it's all the tooling and the components we've built around it. So the blockchain is at the center, and then we build a lot of additional software I'll show you around, tools that make that software a lot easier, such as SDKs, dashboard, so that people can much more quickly build proper dApps on top of that. So at the end, in one sentence, what we build is really a decentralized storage processing platform for IoT data, and that is designed to build, run enterprise-grade physical dApps. I don't know if that's a thing, but I just launched it. Physical dApps, remember? 2018, Berlin. Good. No, but seriously, all the technology is fully open sourced. All of the processes are coordinated by blockchain. It's designed for IoT sensor data. I will show you an example. By developers, for developers. There's built-in product serialization. Serialization means how a big company like pharmaceutical can put a unique serial number on each one of their pharmaceutical products. All of that is built in the technology. That's obviously integrated with GS1. GS1 is the main standard body for barcode. So every time you see a barcode somewhere, every time you hear beep in a supermarket, that's a few pennies that goes in GS1 pockets. Remember that too? And it's very low cost. And that's very, very important, because most of the software in supply chain is very expensive, very antique, very hardcore to maintain. Good luck working with some of those technologies. So we tried to do something very, very fresh, open source, lightweight, that can support those heavy enterprise scenarios. So the first thing to understand is that if you look in a supply chain, you have all sorts of things. You have pallets, you have packets, you have transport units, you have purchase orders. And what we wanted to do, first of all, is to record all those products, the identities of every single one of those products on AMB-NET. That's what we call assets. So an asset is really a physical or even logical entity, such as a purchase order, that needs to have a globally unique identity, unique number, if you want, serial number, and you want to be able to prove the existence and history of that product cryptographically, and you can prove it. Now, this is nice, but the asset is only the placeholder. It's only a unique ID. So what you want to do next is use what we call events. Events are tiny documents that, for example, you can have this container. At some point, you will clean it. At some point, you close it. You ship it. You transport it. You measure it. You break it, repair it, and so on and so forth. And for every single asset, you can create as many events as you want. And you can store all of those events when they happen, because not all events happen at the same time. Those things, you will store them somehow, and you want to be able to prove that, yeah, this event really occurred at that time in that space. And the main pieces of information in the event is who. Well, who has signed, who has said, yeah, this event happened. For example, if I take a barcode scanner, he's scanning a pallet, the who in this case is the scanner. He's the one, assuming he's signing your transaction, of course. This guy might have a crypto chip and a private key in it, and he's the one sending data around it. So you can trust that maybe that device or someone having its private key has created that event. The what? Obviously, you want to know the identity. So now the what, if you just have an ID, then it's easy to copy that ID somewhere else. So you might want to have additional security here that really proves this thing really so here. For example, you can imagine having much smarter RFID scanners, stickers, and so on. The where, location, when, timestamp, and why is essentially what happened. The product passed the customs, or the box was scanned, was opened. So this is the data you would store with every event. This is an event. And of course, you can add as many attributes as you want, temperature, all sorts of data. So what's really interesting is that there is only one API we've built out there. And in that API, you can use pallets, products, and all sorts of sensor data as well. And that's based on a lot of research we've done over the last 10 years in the Web of Things space. We launched a standard around that with W3C. So there's a lot of work that has been put into that. And the advantage of having those REST APIs is that you can suddenly don't know anything about blockchain, but you can just start using those REST APIs, and you have a real dApp working. Might not be as secure as you interacting directly with the blockchain, but it's very, very fast. And that's very important for companies, because in a few hours, in a few days, they can build a prototype, they can test it, they can see it's working without hiring a bunch of Ethereum developers if they manage to find them. And finally, obviously, we try really to focus on productivity, make it as easier as possible. So in terms of the architecture, how it works, so I mentioned before that the blockchain is just an element at the center. So our blockchain, I'll say a few words on the next slide. Well, I'll just do it now and then come back. So our blockchain is fully functional. It's based on Ethereum. It's a proof of authority network. It's permissioned, because for enterprises, they want to know kind of who plays around with their data. So the validators are all KYC'd, and they sign a contract to be able to be a validator. But then that means you have a network where every single node of authority is reliable and trusted, which was very important for companies. We'll be evolving and opening that up to other community members, of course, but it's really important for the core validator. It's scalable, it's entirely compatible with Ethereum, and that's just the core. And we have it already, we have our mainnet that we launched a few weeks back. It's still a private mainnet in the sense that we're just testing and we're onboarding new nodes since last week. So you can actually, if you're interested, we can talk afterwards and I can show you how to apply. We got a lot of applications for people, and that was like pretty overwhelming how many people were interested in running a node. But the point is that this is just the core blockchain element. And there's not, the most exciting part happens in what we build in those black dots here. That's what we call the Hermes nodes. And that's what I will demo in a bit. And the whole point, what a Hermes node is, essentially it provides a REST APIs to devices, to apps, to tablets, to different more standard things to talk directly with a blockchain. And they store data as well. And I'll zoom into that later. But the whole point here is that every company can run a Hermes node. That Hermes node, they can run it in their data center. They can store a lot of private data here if they don't want to share, because not all companies want to share all the data, and yet still put a proof of that data on the blockchain on AMB-NET. And that's very important, because even if it's public, even if it's private data, maybe 6 months, 12 months later, there's a scandal. Authorities come and say, hey, you have to prove me that this check was done in that way at that time. And today, they can still go in their database and falsify some documents, say, here, and you can't trust. Now, you can't do that anymore, because every single data they record here is going to be put the proof of it is going to be put on a blockchain. So I'll just show you the last schematics, how that works. So essentially, that's what I meant, Hermes node, right? So a Hermes node, think of it like a gateway. And it's open source. You can go there. You can download it. You can start playing around with it. And what that gateway does, it offers you a REST API. All of that is pretty classic cloud here, if you want. REST API, it stores private data either in a local database or whichever database you want. This is happening in a private cloud of a company or an organization, so everything coming here is private. But every time they store some data here and they want to prove it later on, so if it's an asset or an event, they will put that in what's called a bundle. And a bundle is essentially a huge file containing 16,000 metadata of assets and events. So it's a huge file, but that file is going to be stored on what we call Atlas nodes. So those are community nodes. Everyone can run it. And everything here and here is public. So everyone can see that data. So if as a company you have something private you don't want to share, you put it here, and you only put the metadata, obviously the hash of that document here. If you want to make that data public, for example, the ingredients of the Club Mate, or when this particular batch of Club Mate was made, then you would put that information publicly and everyone will be able to see. And then the blockchain part obviously coordinates and rewards nodes and themselves, and the Hermes node will pay every time they want to upload a bundle, and obviously they put the proof which is recorded in transactions on the blockchain. Demo clock. Do we have time? I guess we have time. 5 minutes. Good. So, questions so far? Okay, after. Good. So I'll just show you how to create events. So let me just do that. So, here. So this is essentially how you do it. Okay, do you see? Does everyone see? Let me just make it larger. Come on. Okay, well, large enough. So essentially, you just send to the URL here. You send to the URL of one of those gateways. This is our own gateway, test one. It's public. Anyone could play around it. You send just this object. And in this object, you have a created by. This is my public key, right? Because I want to say and prove that I myself have created that document. I'll send a timestamp, which is current timestamp, and a sequence. If I want to create many assets in 1 second or in one request, then I can just increase that number so I can have many of those with the same timestamp and user address. So I'll just send my request. This is classic REST, nothing fancy, and you see a tool1 created. So now what's really important here is that we see a few things. I send a content document with an IT data field, and now in the response I get from the server, I get a signature. So that signature is essentially this data, this entire object, signed by the private key corresponding to this public address, right? So when I do that, then even if I modify that, I will be able to prove, hey, was this signature really done by this address or not? So if someone modifies or creates wrong data, they won't be able to create data on someone else's behalf. That's the first thing. The second is the asset ID, and the asset ID is the Ketchak hash of that element here, right? And this is the asset ID. It's globally unique, and this is the ID of that asset I've just created. You'll see metadata, bundle ID. It's null because it hasn't been yet put on the blockchain, and when it was uploaded, so when the Hermes node has received it. So what I'm going to do now is I'm going to take the asset ID I've just created, and you can just open a browser, and you can just go in your browser here. Hold on. And this is just on the Hermes gateway, right? It's publicly accessible. Output that data. And here, this is essentially, do you see? So essentially, it's almost what I've seen before. The only difference is now there's a bundle ID because that has been put in one of the bundle. I can go on the chain and verify if this bundle was re-uploaded, if it contains that asset, and so on and so forth. Now, we look about events. I'll go here, events, and you can see there's 0 event on that thing. So let's create an event. So to create an event, pretty much the same concept. Now, again, I use the asset ID in URL / events. That's the asset ID I've just done. Same principle, ID data. I'm going to put the ID of the object I'm creating. The reason I want to put it here and in the URL as well is because if I just put it in URL, then you won't be able to prove that this event really belonged to that asset ID, because that's going to be part of the signature afterwards. That's the reason you want to put it here on top of having it there as well. And then my user address, timestamp, I can put whatever I want. And let's say we have this awesome bio Rhabarber Schörle from Fritz Spritz. So you can just add data about this product. I can put the size. I can add all sorts of information I want. Pretty classic, nothing particular. And then I use this, so identifiers. And here I can use, for example, if I put an RFID tag on that product, I'll just add the unique ID here, GTIN and all of that, right? So I'm going to send that information. It's here, same principle as before. I have a signature which proves it here. Again, no bundle ID because I've just created, and that's the ID of the event. So I go back here, I just refresh, and now I can see my event. So this is very interesting because now I can just go to, I can just create a very, very simple application that displays that data. That can be a loyalty app or anything that clients want to. So I'll go on m.2. And I just enter this asset, and that URL here is the one I will put on a QR code specific on the product, and it's loading a bit slowly. And this is what I've just created with the data and so on. There's no other event. It's a bit boring, but you have all that data. This, of course, is open source. You can download, you can extend, you can add a lot of fancier stuff than we've done. But now it's not very interesting. There's not much happening. So let's create another event. that product was scanned. So here again, you have data, same principle, and we put a location. We say, yeah, it was here, that's the address. So you'll send this event, again, to one creating, and you go back here, you refresh, and you can see now that this asset was scanned 9 seconds ago in Berlin, and you can see the details. And of course, you have all the hashes and everything I've shown before. Now, this is very interesting. It's very convenient to do all of that. One of the things I really want to show is this, and then I'm done. So GS1, I mentioned before, is one of the main organizations that is standardizing QR codes. And they standardized that stuff in '74. And it's pretty boring, like it's just an ID, so the namespace is kind of limited to 13 million products. And there are a few more unique products in the world. I think that's the number of Coke an American school consumes in 1 week. So sorry for the bad joke, but I couldn't resist. So, and now what they've done, like literally a few weeks ago in August, they have launched what's called GS1 Data Link. And that's essentially the version of that for the future, which is a QR code. And they're trying to standardize the URL structure that you put in there. Why is that important? Is that the same barcode can be not only read by a machine, because you have exactly this ID here. So when you go to your shopping register, you just put this QR code. It's going to be able to scan, because most barcode scanner in register can also scan QR codes. Now they will have a standard to do it. And at the same time, you just enter this URL in your browser, and all of that is created automatically, just because you have created an asset in Ambrosus. So that's really important, because everything what I was explaining, the whole point of that is, as a company, you can now start implementing any sorts of stuff very, very quickly that would have taken years to build. And if you take GS1 Data Link, which came 1 month ago, we built it in like a few days at most. And the point is that it's not going to be in most supply chain software for next few years. So this is the flexibility you can get with using such kind of technology. And you can just go open this URL, or you can scan it with your QR code, of course. You just open it. And if everything works perfectly, just open that, and you land automatically on the bio-rhubarber schorle. So it's just going to redirect that I've just created. So that's the main demo. And I think that's it. So maybe just the last word. So all of what I've shown is online. Most of the documentation is on our GitHub. You can go on tech.ambrosus.com. That's where you have the APIs, documentation, SDKs to build that. We have just launched a program where we want to provide financial support and tech support on all sorts of projects that want to build something on top of AMB-NET. This was mostly supply chain, but you can use the technology, I guess, for a bunch of other things. It's up to you, really. You can host Hermes node, join our team, support us, and get the last t-shirt, because we didn't have many this time. And if you have anything, tech@ambrosus.com, and happy to support you. So come talk to us, and happy to meet you. Thank you.